All right, so we've been talking about a new kind of equilibrium, the equilibrium of a solid dissolving in solution, right? Something that's generally considered to be insoluble, but we're learning that even something that is insoluble based on solubility rules can dissolve a little bit, right?
Yeah, so we have a K to tell us how soluble something is.
Very good. Now, if that K is a large value, what does that tell us about the solubility?
Does that mean it's soluble?
That's right. The higher the value, the more soluble it is. So we have a K for the solubility of barium phosphate, 1.3 times 10 to the minus 29. So what does that tell us?
Low, not very soluble.
Very good, not very soluble. But we can calculate the molar solubility from this. We can identify what the molar concentration of the material that actually does dissolve, right? So how do we do that?
It's the KSP times, set equal to the equilibrium concentrations, right? Or the equilibrium, what do you call it? The equilibrium statement, the equilibrium.
The mass action expression, the equilibrium expression?
Yeah, the equilibrium expression.
Okay, yeah. So what is the equilibrium expression for this one?
Concentration of barium ion times the concentration of phosphate ion.
All right. Folks at home, if you think you know how to do this, this is a good opportunity to exercise. So I would push pause right now if you have an idea how to solve this one and try to solve it for yourself, okay? It's very, very, very important to do, especially if you think you know. And even if you don't think you know, if you do it and then I show you, then you will fix the errors. If you don't do it and I just show you, you'll have to wait till the next time to have the opportunity to fix the errors. So please try it at home. Push pause. All right, so they're back. They're ready to go now.
All right, so you put the concentration of barium ion.
What is the barium ion? Is it a +2 charge?
Yeah, that cubed, concentration of phosphate ion squared.
Like that?
Yeah. And then set that equal to 1.3 times 10 to the minus 29.
Like that?
Yep. Now, can you just do x cubed times x squared equals 1.3 times 10 to the 20? No, you can't do that. There were numbers last time. I can't remember what you do exactly.
Well, a good thing to do to help you remember is to use an ice table.
Okay.
So the ice table will kind of visualize it for us, right? So in the ice table, essentially what we're doing is we're looking at barium phosphate dissociating into barium ion and phosphate ion, but there's 2 phosphates and 3 bariums, okay? So what that means is for ice, the change, there's none of this to start with, right? And the change is plus 3x because there's 3 there.
Oh, yeah, that's it. And then plus 2x for that one.
That's right. Okay, now how does that help?
Well, then that's equilibrium concentration is just 3x and 2x. And then you use those values cubed and squared.
Very good. So you put 3x cubed there and 2x squared here. So this is 27x cubed and 4x squared, which equals 108x to the 5th, right? I just remember that because we did that last time, right?
Yeah.
Okay. So that equals 1.3 times 10 to the minus 29. 1.3 times 10 to the minus 29 divided by 108. And then I'm going to raise it to the 1/5 power to take the cube root. 6.5 times 10 to the minus 7. And that is the molar solubility. Now, they asked for the molar solubility. They didn't ask for the barium ion concentration. If they had asked for the barium ion concentration, what would we have done?
Would you multiply it by 3 and then cube it?
Well, you wouldn't need to cube it, but it would just be in this ice table here. The concentration of barium ion at equilibrium is not cubed. it is just multiplied by 3. And the concentration of the phosphate ion would be this molar solubility times 2. Okay, good. All right, here's another opportunity for you then. And that's the solubility of the salt, and we're going to try to find out what the KSP is. Take a second, see if you can figure this out without help. You have any ideas, Fred?
Oh, I think I got it. So if you take like 3 times 10 to the minus 5, and that's the molar solubility, that's our X value, right?
That's right.
And then we got A2B3, so it's going to be the KSP is going to be equal to concentration of 2A squared.
All right, so you can see that ice table in your head, huh?
Yeah, I got it now. So then the 3B cubed.
Okay, 3B cubed. So let's take a look at what Fred has seen here. A2B3 dissociates into 2A's and 3B's. All right, and so, this is our cation plus charge, anion minus charge there, right? And we don't need to worry about what the charges are, but it's probably not going to be +2 or not just +1 or -1, right? It can't be. This is going to have to be a +3, and this is going to have to be a -2. But you don't need to have those correct to get the right answer here. But for the ice table then, what we have is initially 0, and then the concentration change is going to be +2x plus 3x here. So it's not the 2a and 3b, but it's 2x and 3x, right?
Oh, yeah.
So 2x, 3x cubed, 2x squared there, right? But the concentration of A is going to be 2A and 3B here. All right, so this is the concentration of A squared, which is 2x's. So we should take those out like that. There we go. All right, and then once again, this looks like 108x to the 5th set equal to our KSP. And we don't know what our KSP is, but we know that the X is 3 times 10 to the minus 5. That's the X. So this time we're going to take 3 times 10 to the minus 5 and then raise it to the 5th power. And that I'm going to multiply by 108 as well, right? And that will be 2.6 times 10 to the minus 21. Okay. Let's see if we got it. Good. Here's another one for you. You want to try to solve that one by yourself?
Yeah, I'll do it.
Okay, push pause, solve it.
Okay, I'm ready.
All right, so what'd you get?
Well, I took 2.5 times 10 to the minus 6 and multiplied it by 2, squared it, and then, well, actually just, and then multiplied by 2.5 times 10 to the minus 6 again.
So you had x being represented for A, 2x represented for B, 2x squared then times x. So this is 4x cubed. Is that what you said?
Well, that's what I was trying to say. Yeah, 4x cubed, and then 2.5 times 10 to the minus 6 goes in for x.
All right, very good. So if you put 2.5 times 10 to the minus 6, cube it, multiply it by 4, that should give you your KSP. Okay, very good. Good place to stop.